Monday, 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 Monday. Morning, Bree.
Good morning.
Okay, here we go. All right, homework. Any questions? So this was on pyramids, one shape, pyramids. All right, see, 1 through 6 was that table. Each column there has 2 answers. And then the rest were basically word form of the same thing. All right, here we go. Number 1, the base edge was 6. I'm going to be very lazy and leave off the word units. And the lateral edge was the square root of 34. Number 2, the base edge was 10, and the lateral edge was root 194. Number 3, slant height was 25, and the lateral edge was the square root of 674. Number 4, the height was 3 root 7, and the base edge was 18. Number 5, the height was 3, and the lateral edge was a square root of 41. Number 6, lateral edge was 2 root 17, and the base edge was 8 root 2. Number 7, lateral area was 36. Once again, being lazy here and leaving off the word square units because we're doing lateral area here. Number 8, 33.75. Number 9, 192. And number 10, 360. And 11 through 14, they ask you to find out the lateral area, the total area, and the volume. So lateral area, that's 1/2 PL. Total area would be 1/2 PL plus the base area, and volume would be 1/3 base area times the height. So here we go. Number 11, let's see, the lateral area is 60. The total area of the surface area would be 96, and the volume is 48. Now, many times the volume is larger than the surface area, but just be careful. We're not comparing apples with apples here. Lateral area or total area, surface area is in square units, volume is in cubic units. So even though the numbers may be smaller or bigger, you're not talking about the same thing. Let's see, 12, lateral area is 320, surface area or total area is 576, and volume is 512. Number 13, let's see, the lateral area is 260, surface area total area is 360, and volume is 400. Lastly, number 14, lateral area is 480, total area is 736, and the volume, it's an ugly number, but no big deal, 256 root 161 over 3. When you do the base area, divide it by 3. The base area is 256 root 161 divided by 3. 3 doesn't go into 256, so you're done. All right, we're moving on. I think this is the correct schedule. Obviously, things have changed a little bit. We're doing this instead of taking our PSAT test. But we're going to finish up chapter 12 on Wednesday, unless we run into some problems. We will do 2 days of review, Thursday, Friday. One of those days, I forget, you guys come back. I forget which day you guys are off quarantine. It's very confusing to me at this point. Make sure you're following the emails. I'll try to have a clearer picture for tomorrow's class so I can say what day you're coming back. What I do know is that we're going to take the 3-day weekend there, come back, and we're going to take the chapter 12 test. And immediately following that, no, I'm not going to do a PSAT prep day. We've done enough of those. Immediately coming back on that Wednesday, you'll take your PSAT. That Tuesday, as you look here, you will physically be back here. That will be a full day of class, normal classes. And then on that Wednesday, you guys will come in for half a day. So Wednesday, that we're talking about next week, not this week. Wednesday, you're going to come in, take your PSAT test, and that will be it for you that day. After the PSAT test is over, you will go home. But that Tuesday is a full day of classes, full day of classes. The ninth graders will be taking their PSAT test on that day. So they'll do a half day, then go home, and then they'll come back on Wednesday for a full day. And then we'll begin. I don't know if we'll actually get to chapter 14. We'll see, but we will certainly start off with chapter 13. We will get through chapter 13, see how far we get. We are 6 weeks out, so you're seeing the half of what's left. And remember, the very last week is nothing but semester finals. So when talking about classes, and I always do a couple of days of review before that. So talking about classes, we're probably looking at about 4 weeks of classes left, maybe 4.5 more precisely. And then we go into 2 or 3 days of review for the finals, and then that last week is finals. Finals will be as it normally is, which means that you'll come in, take your finals, go home. It'll be half-day schedules. Last week of school. All right, here's your homework for tonight. 2 shapes today. 2 shapes today. All right, here we go. Cylinders and cones. Cylinders and cones. It's a different drill, a different day, same drill. Give you a shape. We're going to be calculating 2 things. We're going to be calculating total area. That's a fancy word for surface area. The lateral area is part of the surface area or the total area. That's just the side area. And then lastly, volume. So same drill, except with cylinders and cones. So 2 different shapes. All right, put this in your book of truth, please. Cylinder. Well, it's a 3-dimensional object, not made up of, it's not polyhedron. So it's a 3-dimensional object. It's made up with 2 congruent circular bases. Think about a soup can. The top and the bottom are circles, and then you have a curved surface that joins them. So we don't say lateral face, or sorry, we don't say the lateral faces are polygons, triangles, or parallelograms. It's a curved surface. That is what a cylinder is. Three-dimensional object with 2 congruent circular bases and a curved surface joining them. The side would be the curved surface. And once again, as I'm teaching this online, if I'm going too quick, you have to stop me. All right, moving on. Parts of a cylinder, this is back to 8th grade and 7th grade. Let's see, we have the bases. Those are the 2 circles. Obviously, I haven't given you the name of it yet, but in a regular cylinder, those 2 circles are directly above each other, right? The bottom and the top and the bottom. Just be careful. I can turn the soup can sideways, and then it's left and right. So the bases are the 2 congruent circles. They are also parallel, so they are on 2 separate planes, and the 2 planes are parallel to each other. Next, we have that curved surface that goes around the cylinder. That is called the lateral area. Same thing for prisms. Lateral area. The difference here is that the lateral area is not a polygon this time, right? It's curved. The height is the perpendicular distance between the 2 circles, right? Pretty obvious. And then I'll pause so you can get all this copied down. Base, lateral area, and height. Base, lateral area, and height. Nothing new here. This is the same stuff that we did in 7th and 8th grade. This is different, though. 2 types of cylinders. We have our right cylinder, and we have our oblique cylinder. So the difference between the 2 is on the right cylinder, the circles are directly above each other. In other words, the height goes through the center of the 2 circles. And on an oblique cylinder, the 2 circles are still parallel. They're just not directly above each other. So the height would not go directly from the center of one circle to the next one. We can still measure the height or the altitude, but it would not be measured through the center of each circle. Now notice those circles there are drawn in 2 dimensions. They are drawn as ellipses. If you draw them as actual circles, it doesn't look right. Drawing 3 dimensions and 2 dimensions squishes one of the dimensions to make it look right. Okay, so right cylinder and oblique cylinder. We will be doing all the math today with right cylinders. Occasionally, we'll talk about oblique cylinders. So think about this. We did do this in 8th grade. We talked about something called a net, N-E-T, net, and a net is a two-dimensional representation of what the surface area would look like. So if you think about a cylinder and you cut the surface out and laid it flat, well, clearly the top and the bottom you'd have two circles, but what would the lateral area look like? The side of a cylinder. If we cut the side out, think of a soup can and a label. If you cut the label off of the soup can and lay the label flat, you would in fact get a rectangle. Can you see that? Right now, obviously the top and the bottom are circles, but that's what the net would look like. The net is just a two-dimensional representation of what the surface area would look like. Okay, so let's see. The surface area of a cylinder is made up of two circles and a rectangle, and that's kind of convenient because we can easily come up with a calculation. Well, the two circles, those would be pi r squared. Let's see, the rectangle in the middle, the height would still be that height of that rectangle, but the other dimension of that rectangle actually ends up being the circumference of one of the bases. Think about that. As you take that soup can and you cut off the label, the length of that rectangle would actually be the circumference of one of the bases. That's pretty convenient because now we can get a formula for the lateral area. So the lateral area, well, it's a rectangle, base times height, or length times width, either one. And the length is the circumference. We know the circumference is 2 pi r. Well, and the height is the height. So we take 2 pi r, change that w to an h, and there is your formula for lateral. Remember, lateral area is just the side length. So we're not including the two circles. So this is actually theorem 12.5. And it says that the lateral area of a cylinder equals the circumference, that's the 2 pi r, of a base times the height of the cylinder, so 2 pi r h. 100% sure, make sure this makes it into your book of truth. Theorem 12.5, the lateral area of a cylinder basically is equal to 2 pi r h, 2 pi r h. That certainly sounds like pi r squared though a little bit, so be careful. Don't mistake it with the area. The lateral area of a cylinder equals the circumference of a base times the height of the cylinder. Circumference of the base is 2 pi r, the height is h, so 2 pi r h. All right, easy formula to use. Remember, lateral area is not total area, and our book does a bad job. I'm not sure why we don't get a theorem on total area, but we don't. It skips it, so here we go. Make sure this winds up in your book of truth as well, too. If the lateral area is 2 pi r h, then the total area, remember, because there'd be two circles, would be 2 pi r h plus two bases. And since the base is a circle in yellow there, that's what you need to write down for your total area. So total area, which is the surface area, is 2 pi r h plus two bases, and the base is a circle. Area of a circle is pi r squared, so plus 2 pi r squared. 2 pi r h plus 2 pi r squared. Tonight for homework, they're going to ask you to calculate the total area. Well, they'll actually calculate the lateral area first, and then they'll say, what is the total area of the cylinder? And you have to use this formula. Lateral area is 2 pi r h. Total area is 2 pi r h plus 2 pi r squared. And that is the surface area, or total area. 2 pi r h plus 2 pi r squared. Once again, stop me if I'm going too quickly, but check it out. It's just a formula with an r and an h. Those are the only variables. So we need a radius and we need a height to do this calculation. So theorem 12.6 deals with the volume. I've heard this explained by, I don't know, stacking circles on top of each other, stacking pizzas, stacking pancakes, that sort of thing. So one pancake, the area would be pi r squared. So if we stack a whole bunch of pi r squareds on top of each other, that would be the height. We get to pi r squared h. So our second formula, we will get 4 today. Our second formula is volume. Volume of a cylinder is pi r squared h. And you had this one from 7th and 8th grade as well. This one's not new. pi r squared h. Total area was 2 pi r h plus 2 pi r squared, and volume is pi r squared h. Very easily confused with each other. So make sure you have them highlighted in your book of truth so you don't make a silly mistake like use the volume formula for total area or vice versa. Pi r squared h, volume. We'll just do a couple of examples. They're not too complicated. As I look at all the homework tonight, it looks like nearly everything you do, they want you to leave things in terms of pi, leaving things in terms of pi. So they don't actually want you to multiply by the 3.14. They want you to leave pi as pi. So let's do this one. Calculate the total area of the cylinder in terms of pi. That just means leave pi as pi. So let's see, we're doing total area. The formula for total area is 2 pi r h plus 2 pi r squared. Let's see what happens when we plug in those numbers. Let's see, the radius is 5. The only way I can trick with you is give you the diameter there. And the height is 4. Plug those two numbers in and then simply simplify. Let's see, 5 times 4 is 20. 20 times 2 is 40. So I get 40 pi. And on that second part, the second term there, I got 5 squared. 5 squared is 25. Double 25 or times it by 2, we get 50. You see where I'm getting those numbers from? 5 times 4 times 2 is 40. 5 squared times 2 is 50. 5 times 5 is 25. 25 times 2 is 50. We can add those together, 40 pi and 50 pi, right? That would be 90 pi. And total area is in square units, so we got centimeters squared. And I can't make this one complicated because it's not that complicated. So there's your one example for total area right there. Now be careful, tonight for homework they have you calculate both lateral area, total area. Remember, lateral area is just the 2 pi r h. So if it was lateral area, the answer would be 40 pi. Total area would be 40 pi plus the 50 pi, so 90 pi centimeters squared. All right, let's do volume. Same cylinder, let's do volume. So we pull up our volume formula, pi r squared h. Once again, it's just an r and an h. Just a matter of plugging numbers in. 5 squared is 25. 25 times 4 is 100. So we get 100 pi. Now remember, volume is in cubic units, so we get cubic centimeters here. And yes, for homework, you get your favorite, the table that you have to fill in, but it's not too bad now that you've seen how this all works. Everything tonight will be done in terms of pi. All right, believe it or not, we're done with cylinders. Let's move on to our second shape, and it is a cone. A cone. All right, so cone is a three-dimensional object with a circular base and a curved surface that curves to a point. Notice, kind of looks like a pyramid a little bit, but the base is not a polygon. The base is a circle. The sides are not triangles. The side is a curved surface, right? Cones. Cones are the one that requires a whole mess of logic to come up with what the formula is. And we'll do that next after we write this one down. Cylinder is pretty easy to explain. Cones are a bit more challenging. All right, let's talk about the parts of a cone first. Parts of a cone. Just like the cylinder, just like the pyramid, same basic idea. Let's see, the base. Well, there's only one base here. You can turn the cone on its side, but the base is the circle. Once again, drawing this in 2 dimensions, we squish the circle down to an ellipse to make it look right. The perpendicular or the curved surface is called the lateral area again. That's the side of the cone. It only has one side, basically. It's curved. It continues on forever. Continues on forever. Continues all the way around the cone. There is no triangle or anything. Although, I mean, visually it kind of looks like a triangle right here. It is not. It's curved surface. The perpendicular distance between the base and the vertex is called the height. And lastly, we still have our friend, the slant height. The slant height would be the perpendicular distance from the edge of the base to the vertex. And yes, just like in the pyramid, you're going to get some right triangles. The base, that's the bottom, or the circular part. Yes, most cones do sit, in fact, on their base. It looks weird. They roll around if they don't. The lateral area is that curved surface that makes up the side. The height is the distance between the base and the vertex. And lastly, the slant height is the distance along the outside of the cone from the edge of the base to the vertex. And it is also measured perpendicularly. Parts of a cone. Base, lateral area, height, slant height. Okay, there were two types of cylinders. There's two types of cones. We call this one a right cone, and we call the second one an oblique cone. The difference between the two is you take the vertex and you move it, right? If the vertex is directly above the center of the circle, then it is a right cylinder, a right cone. If the vertex is not above the center of the circle, we call it an oblique cone. We had oblique pyramids, we had oblique cylinders, we have oblique cones. Okay, now comes the thinking part. All right, so I'm going to show you two different cones, one large, the one on the left there, and a smaller one that's going to appear to the right. So we got to figure out the surface area, the total area, right? So think about taking a pair of scissors and making the net of the cone. So you can kind of see what they did right here. So they cut off the base, right? That would be a circle. That's easy, pi r squared. It's the shape of the side that's the hardest one to envision, right? The shape of the side. If we lay that flat, I'm going to show you a different cone, not the same size as this one, a different one. If we lay it flat, it would actually look like this, and I've color coded these to help you out here. So that cone there, look at the right one now. The cone there has a base that's, I don't know if that's brown or orange, and the side is blue. The base has a radius of r, and when we lay open the net of the side, the lateral area, we get a, I don't know, Miss Pac-Man looking thing with a big open mouth there, the blue part. Notice it also is a circle, but it's not the full circle. It's part of a circle right there. I labeled A, B, and C just so that we can name that arc there, A, B, C. The slant height there, which is L, notice ends up being the radius of the lateral area, or the lateral portion of it. The radius of the circle we'll call r. So I have two different radii there, and they are absolutely different shaped circles. One's big, the Miss Pac-Man, the blue one, and the brown one is a much smaller circle. We got to somehow come up with a formula for both lateral area and total area for this one. So we're going to focus first on just the lateral area, just the lateral area. So this one requires you to put your thinking cap on. It's a little bit harder. All right, so let's see if we can figure this one out. If you remember, the blue part there is a sector of a larger circle, right? Sector just means a part of it, right? And to calculate the area of a sector from the previous chapter, well, you take the central angle, that's the x, divided by 360, right? 360 degrees in a full circle, and that would give us a percentage, right, as a decimal. So it's a percentage of the full circle. And if you multiply that by the area of the circle, then you get the area of the sector. Now, this is straight from last chapter. Now, notice I didn't put pi r squared. I put pi l squared because I'm talking about the blue circle. If I was talking about the brown circle, I would have said pi r squared. So I'm talking about the blue circle here. That's why it says pi l squared. But trust me, we're still talking about pi times the radius squared. All right, so if I can do this formula right here, that would give us the area of the blue. Well, we got a problem here is because I got an x and I don't have any angles here. I mean, it doesn't tell us what the angle is. In fact, I'm not even sure. It looks to be obtuse angle, but I don't know what that would be. Now remember, x over 360 is just a percentage. I need a percentage, and there's a second way of calculating that percentage. Well, if you think about the circumference of the circle, then arc ABC, can you see arc ABC? That arc length, right? The arc length of ABC would be the same percentage of the entire circle, right? So we could rewrite this form. Instead of having X, we could put the arc length of ABC. Instead of writing 360, we could put the circumference of that blue circle. And that would be the same percentage. It wouldn't be any different. And the reason why I want to do this one is because I can come up with this formula a little bit better. Watch this magic. Let's see, the arc length of ABC, the arc length of ABC, now here comes the magic. Look at arc length ABC and go back to the original cone, the one there just to the left of the net of ABC. And notice arc length ABC, that would be the distance around the outside of the Miss Pac-Man, the blue part, would actually be the circumference of the brown circle. Can you see that? Arc length ABC would actually be the circumference of the brown circle. And the brown circle, let's see, has a radius of r. So that arc length, which is the circumference of the brown one, would be 2 pi r. The circumference of the blue one, because it has a radius of L slant height, would be 2 pi, not r, but 2 pi L. So watch this magic. Do you see that? The arc length of ABC would be the circumference of the brown circle, and the circumference of the blue one would be 2 pi L. And the reason why I like this is because look, a whole bunch of canceling can take place. The 2's cancel, the pi's cancel, and even one of the L's cancels. One of the L on the bottom, one of the L on the top. So after everything cancels, well, there's no L on the bottom. In fact, I have no denominator anymore. I'm just left with an R, a pi, and one L, and that ends up being the area of sector ABC. Why do we care about that? Because that is the lateral area. The lateral area, the Pac-Man, the blue part, is pi RL. And that is theorem 12.7. So the lateral area of a cone equals the product, that means multiplication of the base, pi, and slant height of the cone, pi RL. Radius of the base is the R, pi is pi, and slant height is that L. All right, that one's not too bad at all. Finding that out, boy, a pretty smart person did that. But for us, we just need to be able to use this formula. It's two variables in pi. And yes, all the answers will be left in terms of pi, so it's just the radius times the slant height, and we're done. Pi RL, pi RL. All right, stop me if I'm going too fast. The big but here, once again, is, well, the book doesn't give us total area or the surface area. It just gives us the lateral area. Well, we can fix this. If the lateral area is pi RL, well, then the total area, the surface area, would be pi RL plus the area of the base, and the area of the base is a circle. So it would be pi RL plus pi R squared. Now notice this is somewhat similar to the formula for total area of a cylinder. Remember, a cylinder would be pi RLH plus 2 pi R squared. And this one just leaves off a little bit there. Right? There's no 2 involves for this one. Total area of, sorry, write this down, please. I'm not sure why I didn't usually highlight this in red, but I didn't. This needs to be in your book of truth. Book of truth. Pi RL plus pi R squared. Easily confused with the cylinder total area. 2 pi RH plus 2 pi R squared. This one's just pi RL plus pi R squared. Nice thing here is just two variables, the radius and the slant height. They're kind of nice to you. They don't make it too complicated. The pyramid one, there's a couple complicated ones. This one's not too bad at all. So let's look at one. It says calculate the surface area of the cone in terms of pi. So we're going to leave pi as pi. Well, let's see. Surface area, that's the total area. Total area is equal to pi RL plus pi r squared. We need the radius and the slant height. Look, we got the radius and slant height. Just be careful, right? They could give you the diameter. Let's see. Radius is 3. The height is 6. We are missing the slant height. We can find the slant height by using Pythagorean theorem. Notice that right triangle there. 6 squared is 36. 3 squared is 9. 36 and 9 is 45. Square root of 45. Let's see, what perfect squares are in 45? 9. 9 times 5. So I get 3 root 5. Remember, 9 times 5 is 45. The square root of 9 is 3. So we get 3 root 5. 3 root 5. So that's just the slant height. We got to plug that into our formula. We have the radius, which is 3. All right. We just figured out that the slant height was 3 root 5. 3 squared is 9. Do you see what I did there? 3 squared is 9. So I get this big honking mess right here. 3 times 3 is 9. And you're like, well, why can't you join that together and get 18 pi root 5? Well, remember, one of those terms has a square root of 5 on it and the other one doesn't. You can only add or subtract like terms. So that big honking mess right there, 9 pi root 5 plus 9 pi, that ends up being the surface or total area of the cone. So these might be very unfriendly looking answers, but to calculate them, it's not too bad. Not too bad. Questions? Pi RL plus pi r squared, leaving it in terms of pi. All right, I said there's 4 total formulas. We're missing one, and that would be the what? The volume? All right, volume. Do you remember this? If I had you all for pre-algebra, do you remember the video I showed you in 8th grade of what the volume is? Maybe you will, maybe you don't. All right, here's the video I showed you.
To fill the cylinder if it is 1/3 of the volume. So let's fill the cone up the first time. And here's the cylinder. Let's fill up our cone for a second time. And a third time.
Okay, the key points of this video is that both the cylinder and the cone have the same base area, so it's the same circle, and they have the same height. And the video shows you that 3 cones make 1 cylinder. 3 cones make 1 cylinder. So you want to know the formula for the volume of a cone, take the formula for the volume of a cylinder, pi r squared h, and divide it by 3, and that would give you 1. All right, so that is theorem 12.8. In yellow is what's in the book. Underneath there is the more calculator friendly one, pi r squared h divided by 3. If you were to plug the top one into your calculator, you'd have to do parentheses, 1 divided by 3, close parentheses, pi times r squared times h. Or calculator friendly, pi r squared h divided by 3. Most people use that bottom one there. Pi r squared h divided by 3 is the volume of a cone, and it is volume, so it will be in cubic units. Cubic units. Cubic units. Pi r squared h divided by 3, measured in cubic units. All right, let's do one back to the same cone we had before. It says calculate the volume. Let's see, to do the volume, we need the volume formula, so we need the radius and the height. And look, we got the radius and the height. The radius is 3 and the height is 6. This is just a matter of plugging those numbers in, doing the math. It says leave it in terms of pi. Let's see, 3 squared is 9. 9 times 6 is 54. 54 divided by 3 ends up being 18. So we get 18 pi units cubed. Can't make this one too complicated because it's not very complicated. What is complicated about today's lesson is trying to keep all 4 of those formulas, total area and volume for both cylinders and cones, straight in your head. Well, luckily for you, you get to use resource card, or you get to use your book of truth. So therefore, you just need to be able to thumb to the right page and write down the formula and not make any silly calculation error, which is always a possibility. All right, as always, the book loves its tables. So Matt, open up your book to page 493 and pick one. Pick one. 9 through 16 is a table. Let's do one together.
1 second, let me go find my book.
Just pick a number between 1 and 16. 9 and 16, sorry.
10.
10. Let's look at number 10. 10's too easy. Pick another one.
4.
9 through 16.
16.
Okay. All right. Assuming that 16 must be the hardest one. All right, let's see. So we are given, let's see, we are given a cone, not a cylinder, but a cone. So we're given a cone. This is roughly what it looks like in the book. And on, that's horrible, but you get the idea. Let's see, on number 16, we are told that the volume, that's it. We're just told that the volume is equal to 324 pi. 324 pi. And we are asked to find out all the other unknowns. The radius, the slant height, what else? The height, the lateral area, and the total area. So we need to find R. We need to find H. We need to find L. We need to find LA. And we need to find TA. All right. So let's see if this one's bad or it's not too bad. Well, the only thing we're given is volume, so we better start off with the volume formula. So the volume formula, let's see, is, pi r squared h divided by 3. And we are told here that, I'll erase the v, and we are told here that the volume is 324 pi. Okay. Any ideas, Matt?
It looks like strange symbols to me.
How about we multiply both sides by 3 to get rid of that 3?
That would make sense.
Okay.
That makes sense.
Both sides by 3, the 3 would cancel on the right side, and on the left side, we get 3 times 4 is 12, carrying my 1. 3 times 2 is 6, plus 1 is 7, and 3 times 3 is 9. We get 972 pi, and that equals pi r squared h. Pi r squared h. All right, we can get rid of the pi, divide both sides by pi, and we get 972. The pi's would drop out, is equal to r squared h. I left off one number. It tells us what the radius is. All right, it tells us the radius is 9. This would be impossible to solve without that. So we already know.
I was about to say that.
We know the radius was 9. Okay. So let's see. I can throw in 9. That would give me what? 972. 9 squared would be what? 81. And an h. All right, I'm grabbing my calculator. Let's see if 972 is divisible by 81. If not, it'll have to be reduced. let's see, 972 divided by 81. I'm getting 12. So we get h is equal to 12. That wasn't bad at all. We get h is 12. Questions on how I got that? So height is this part, and now we know that the height is 12. And now we can do all the rest. All right, slant height. The slant height is what? On the side, and now we have a right triangle, right? Right triangle. So that would be what? 12 squared plus 9 squared, and that would be equal to L squared. So that's 144 plus 81, and that equals L squared. Add those two. 1 plus 4 is 5. 8 plus 4 is 12. Carry your 1. And 1 plus 1 is 2. So 225. Oh, look at us. Another perfect square. You remember 225? Take the square root of both sides. And L is equal to 15. Now, some of you quicker people might have noticed that this is a 3, 4, 5 triangle, just doubled. Or yeah, times by 3, sorry. 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. Sometimes you notice those things, sometimes you don't. All right. Last two, I simply need to do the lateral area and the total area. And lateral area is part of the total area. So let's see, lateral area. I'm not sure why I wrote that because that's the slant height symbol. Lateral area, there we go. I look at my book of truth. We just did it. I've already forgotten it. I'm speaking like one of you guys. Lateral area. Anybody got it? Formula? Pi times the radius times the slant height. So that's pretty simple. Lateral area, all I got to do is type in pi. And it said leave it in terms of pi, so pi is going to stay pi. Pi, the radius is 9, and the slant height was 15. So it's really just 9 times 15. So 9 times 15, let's see, 9 times 5, 45, carry over 4. 9 times 1, 9 plus 4 is 13, 135 pi. So 135 pi. All I'm doing is using the formulas one at a time. Not bad. Lastly, total area, or surface area. Remember, the surface area or total area is equal to the lateral area, which is pi RL, which we just figured out was 135 pi. So 135 pi, that's pi RL, plus pi r squared, one base area, pi r squared. And let's see, the radius is 9, so that's 81 pi. So let's see, that would be 135 pi, that's the lateral area. Radius was 9, 9 squared is 81, so we get 81 pi. Add those two together, and we get total area. So let's see, 8 plus 5 is a 6. 8 and 3 is 11. Carry your 1, and 1 plus 2, 1 is 2. I get 216 pi. Let's see, this would be units, 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 units. I'm sorry, lateral area is units squared, and total area is units squared as well too. All right, let me check the book here. Let's see, the height is 12. The slant height's 15. The lateral area is 135, and the total area is 216. We did it correctly. Look at that. All right. Any questions on anything we did today? 16 it ended up being not a big deal. It's pretty simple to do. The table isn't too bad. Let's see. What did I give you tonight for homework? Last page. I gave you 1 through 16 is that table, and then 18 and 19. So 18 and 19 deal with cylinders. 9 through 16 is all cones. Cone is the harder one to mess with. Hey, believe it or not, we've arrived at the end of class. We've wasted another perfectly good 45 minutes of class period doing a whole bunch of fun math. Any questions on anything we did today? Okay. Hey, make sure you stay motivated. Make sure you stay up with your work so that we come back to class. We're not, and I'm not going to lie to you in the sense of we got to be ready for that test, which is coming up pretty. This is a very quick test. Very quick.
What's motivation?
Yeah, exactly. Exactly. We really only have one more 12 point. There's, although it goes to 12.5, 12.4 deals with spheres, and that's the last shape for the entire chapter. 12.5 deals with something else. We'll do that one, and then we will jump right to review for test, and away we go. So technically, after tomorrow, we get 2 formulas for tomorrow. After we get the formulas for tomorrow, we are done with formulas type thing. So hanging tough, but like I said, if you're blowing off the homework, if you're blowing off the work, then the test, which is more to the easy side than it is to the more challenging side, you're definitely not taking advantage of the fact that this is some of the more easier of the material. Any questions? All right, we'll end it right there. You guys have a wonderful day, and I will see you tomorrow.